Okay, so now what are some implications for us to kind of finish up my taxing you? Let's look at this verse from Surah Al-Anbiya that أَوَلَمْ يَرَى الَّذِينَ كَفَرُوا أَنَّ السَّمَوَاتِ وَالْأَرْضَ كَانَتَا رَتْقًا فَفَتَقْنَاهُمَا. This is, in my mind, the current understanding of this verse is the Big Bang. Are they then who are bent on denying the truth not aware that the heavens and the earth were once one single entity which we then parted asunder? Everything was together and we ripped it asunder, we cleaved it asunder. Certainly one way to understand this is that this is referring to the Big Bang. And again, this verse would have been entirely counter to scientific understanding until 1915. Right? Because the earth and the heavens were not one single entity. Here's the earth, here's a star, here's the sun, here's a planet, and they're static and unchanging and eternal. They were not together and we've cleaved them apart. But the Big Bang says, yes, they were. And again, the Quranic Arabic. What does fataqa mean? Fataqa means to forcefully tear something apart. It doesn't mean to gently separate. You know, like that game pickup sticks where you gently, whatever. No, it means you tore them apart. And so this verse is a scientifically revolutionary verse. It would not have made sense to people in 700 or the year 1000 or the year 1500 or the year 1900. The Qur'an statement on the universe, وَالسَّمَاءَ بَنَيْنَاهَا بِأَيْدٍ وَإِنَّا لَمُوسِعُونَ. And it is we who have built the universe with power, and verily it is we who are steadily expanding it. The Qur'an said the universe is expanding. And I've already gone through the whole story with you. I don't need to reiterate how revolutionary a concept it was that the universe was expanding. That's why Hubble won the Nobel Prize. That's why the Hubble telescope is named the Hubble telescope. Because this was entirely revolutionary in terms of human understanding. But the Qur'an is telling us, we have built it with power and we are expanding it. And again, that would have been entirely counterintuitive, and that's why the materialists felt so good. Because in 1600 and 1700 and 1800, when Laplace said, I have no need of these religious texts, they're all wrong. It turns out they were not all wrong, they're all right. And we, alhamdulillah, live in an age where we now understand that they are, and that's a privilege, right? So we should give it its due. So yes, I know it's hard to study physics. A lot of kids, oh, math is boring. Oh, I hate math. Oh, you shouldn't, because it's remarkable. And we are very lucky that we are not Muslims living in the 1800s trying to reconcile that the universe is static, but the Quran says it's expanding. Oh my gosh, what am I going to do? We live in a very, very privileged age where the turnaround has come. And science has progressed to a point that the universe really looks like the way the Quran says it looks like. And this expansion, this idea of expansion is, it turns out to be even more profound than just simply the universe is expanding. Einstein's view and Hubble's view and everyone's view is that, think of when you watch fireworks on the 4th of July. Something explodes, these fireworks, and the pieces move apart, but they're going to move apart at a slower and slower rate. It's first the force of the explosion drives them apart at a tremendous speed, and then they sort of slow down, okay? And the same thing would happen if we accept the Big Bang. The Big Bang explodes everything, and then as things are expanding, well, there's a force of gravity that's tending to attract these bits to each other, just like an apple gets attracted to the earth and falls down. So there will be a slowdown in the expansion rate. That's only natural because that's what the force of gravity does. So the universe is expanding, but of course it was expanding most quickly at the time of the Big Bang, and then a little bit slower, a little bit slower, a little bit slower, and it's kind of slowly expanding outward. The same thing, and this brings us to the notion of an escape velocity, because it's the same idea of gravity pulling stuff to the earth. I throw a ball up, it goes up, then it comes down. I throw it up harder, it goes up a little further, but it's still going to come down. I take a bullet and I fire it up. It goes up and it comes down. That's why they tell you don't shoot bullets in the air, because they're going to go up and then they're going to come back down, and if, God forbid, they land on somebody's head, you can show that they're going to land with the same speed that they went up. So you kill people that way. So is it conceivable that I could throw something up fast enough that it wouldn't come back down? Well, certainly to people well into the 1800s, no. You know, gravity would bring everything down, but I shouldn't say to the layperson of the 1800s, it would have been inconceivable. To the scientist of the 1800s, once Newton's laws were discovered, you can do calculations, and this is actually a very, very neat derivation, but I won't tax you with it. If you studied calculus, it's a very nice problem. You can show that there is such a thing called an escape velocity, where if you throw something up fast enough, gravity won't be strong enough to pull it down, the Earth's gravity. And it turns out that that's at about 11 kilometers an hour. A second, forgive me. So if I could throw a rock up at 11 kilometers per second, then it will actually escape the Earth's gravity. So there is this notion known as escape velocity. But because even when we created bullets and gunpowder, you fire a bullet, that's not moving fast enough to come back down. That's not moving fast enough to reach escape velocity, it will come back down. Your layperson of the 1800s or early 1900s, before we actually could fire rockets off into space and escape the Earth's gravitational pull, would have said it's impossible. You can't escape the Earth's gravity. And here the Qur'an is saying, Ya ma'shar al-jinni wal-ins, in istata'tum an tanfudhu min aqtari samawati wal-ard, fanfudhu. La tanfudhuna illa bisultan. O ye assembly of jinn and men, if you can pass beyond the zones of heaven and earth, pass. But you will not pass without power or without some authority. And it is on the basis of this verse, by the way, that when the first moon landing took place and it was announced, there were Muslims, Muslims who were offering public opinions, who were saying this is a hoax, this is untrue, because the Quran says you can't do it. But again, if you've studied some science, you realize that science tells you can do it, and the Quran doesn't say you can't do it. It just says you're going to need some power to do it. And you're going to need some serious power, because to launch something to escape velocity needs serious power. But if you have that power, you can do it. And it was kind of one of the minor shameful episodes in our history vis-a-vis science, the fatwas that this is haram to believe that man has reached the moon and so on and so forth. So this same idea of escape velocity, something here, you throw it up, it comes back down to the earth, you throw it up, it comes back down, you throw it up fast enough, it escapes. This same idea has to do with the fate of the universe. Think about the universe expanding from the Big Bang. We said the force of gravity will tend to pull matter back together. The question is the matter expanding fast enough to reach escape velocity? What will happen ultimately to the universe? If the force of gravity is too strong, like if I throw a rock up, it will come back down. If the force of gravity is strong enough, the expansion will eventually halt, and all of that matter will come back together. Just like I throw the apple up, it comes back down. If the expansion is so fast that it has reached escape velocity, then the universe will keep expanding, and it will keep expanding without bound. And that is a question that cosmologists are wrestling with. How much matter is there in the universe? And is this matter enough to exert enough force to prevent the universe from reaching escape velocity. So these are sort of the three possible fates of the universe depending on what is known as the mass density. How much mass is there per cubic foot? And if there's too little mass, the universe would keep expanding, and that expansion would never slow down. If there's just the critical mass, it will keep expanding, but that expansion rate would eventually reach a zero. And that is known as the critical mass. And if there's so much matter, that expansion would stop and then reverse, and the stone falls back down, and the universe will collapse on itself. And so these would be the three different so-called geometries of space-time. If the universe is closed on itself, then in a two-dimensional analogy, it would be like the surface of a sphere. If it is open, it would be like the surface of a saddle, and if it is critical, it would be like a flat sheet. And so cosmologists are very busy trying to measure sorry, I'm just going to hold this, it's starting to squeeze my head. They're trying to measure what kind of universe do we live in. And by the way, just like the surface of a sphere is a closed geometry, it has positive curvature in mathematical terms. Oh, sorry. The surface of a sphere has positive curvature. That it means that if you, just like Magellan did, if you start at one point and go all the way and you come back to where you started. If the universe is closed, if it has a closed curvature, that means that if I take a spaceship and go in some direction, eventually I would come back to where I started, okay? Because even though it's 3 dimensions, not 2 dimensions, or really 4 dimensions if you include time, it's the exact same idea as the 2-dimensional surface of a sphere. Space closes in on itself. And we don't yet know what kind of universe we live in. When cosmologists started to try to measure how much mass is there, they discovered something quite startling. When they started to try to weigh the universe, they discovered that, hey, when we look at the motion of the galaxies and so on, and we can measure how much mass, and then we look at the stars, and we add up that mass, this doesn't make sense. We know the equations of general relativity are right. Closer. Okay, I better let my head be squeezed. Oh, thank you, sir. Testing, testing. Okay. So we know that the equations of general relativity are right. We believe God knows best. But the galaxies are moving. Thank you.
Sorry.
Thank you, sir. The galaxies are moving in such a way as if there's a lot more mass. You know, the galaxies cluster and stars revolve around the center of a galaxy and so on. They're moving as if there's a lot more mass than we actually see. And something was discovered, what is so-called dark matter. And it turns out that most of matter, 90% of it in fact, is made of something completely unknown to us. We think that the whole universe is atoms, and that those atoms are made of protons and electrons and neutrons, and we were so happy to discover that, and it was a wonderful discovery, and that that's what matter is. But it turns out that that's actually only a very small part of matter. 90% of matter is not made of electrons and protons and neutrons, and we know that those things are made of even smaller things, the baryons and the leptons and the quarks. 90% of matter is not made of that at all. What is it made of? We have no idea. That's why it's called dark matter, but there's something very profound between the galaxies and the stars that scientists now call dark matter, and it's known to us only because of its gravitational effect. So that's another illustration of a huge illusion, that our matter is what matter is. That's the real, no. It actually turns out that our matter is just a very special case. Most matter is something else entirely, and science has not yet discovered what dark matter is made of. There are a lot of theories out there that we don't need to go into, but What we do need to go into is this. أَوَلَمْ يَتَفَكَّرُوا فِي أَنفُسِهِمْ. Did they not think about themselves? ما خلق الله السماوات والأرض وما بينهما إلا بالحق وأجل مسمى وإن كثيرا من الناس بلقاء ربهم لكافرون. Did they not did they not reflect that God did not create the heavens and the earth and what is between them except with an inner truth and with an appointed period, an appointed term? To me, the modern interpretation of وَمَا بَيْنَهُمَا is dark matter. And I would God knows best, but it is another way to think about the Qur'an. So that we don't, when I was younger, I'd just read this verse and gloss over it. I didn't even think, what does وَمَا بَيْنَهُمَا mean? What is between them? So then I got curious. Said, okay, what did the classical commentators make of this? So I went back to our classical books of tafsir. If you want to pick up tafsir al-Tabari or Zamakhshari or Ibn Kathir, a lot of them didn't mention وَمَا بَيْنَهُمَا at all. It's just, you create the heavens and the earth. Those who mentioned it said, well, what's between the heavens and the earth? Well, it's the trees and the people because they're between the surface of the earth and the heavens. I don't know, it seems to me that the Qur'an is talking about a much more profound truth here. That there's what we see, our heavens, our earth, made up of our matter, and what is between them, the dark matter. And there is essentially no debate now among cosmologists that were it not for dark matter, life in the universe would not be possible. And that's the topic of a whole nother lecture series if the audience is interested. And that has to do with what are known as the cosmic coincidences. Why wouldn't it be possible? Because there wouldn't have been enough gravitation for stars to coalesce and become stars and for galaxies to form and become... There are a lot of good reasons why dark matter, وَمَا بَيْنَهُمَا, is essential to the existence of life. It basically helped to balance the rate of expansion. And so when we think of the Big Bang as this explosion, it wasn't this haphazard explosion like a bomb goes off. My gosh, I'm using all of these bad terms. Bullets, bombs, snipers, line of sight. I mean, if this were taken out of context, there's going to be a raid on the center. All right. But if the Big Bang was not this haphazard explosion, let's think through it a little bit. If the explosion were so fast, every bit of matter would disperse so quickly it would reach escape velocity and it wouldn't come back together to form things like stars and planets. If the expansion rate were too slow, before stars and planets could form, it would have gone whoop and come right back together. So this rate has to be perfectly balanced for things to unfold the way they unfold. And in fact, when it is calculated as to how balanced it has to be, it's not 1 part in a million or 1 part in a billion or 1 part in a trillion. It's 1 in 10 to the 60. It is one of the most precise balancing points that science knows. And the precision that needed to be is absolutely remarkable. And that precision is there because of dark matter. And so in the book Cosmic Coincidences by the physicists and astronomer Gribben and Rees, and yet without the dark matter, the invisible stuff of the universe itself would be a very different place and we would not exist. Does the dark stuff exist? In a sense, for our benefit. So again, the idea that science is now showing that creation is very, very deliberate. Again, these people are not religious people. They're not saying this to show God exists. They're talking as scientists. And science is now beginning to ask the question, oh my gosh, it seems there are a lot of these really weird coincidences that if things were just a little bit different, we wouldn't exist. Why is it that way? We always used to think, well, if the law of gravity, if Newton's gravitational constant were a little stronger, the apple would just fall a little faster. What's the big deal? Turns out it's a very big deal. And that if it were just a little bit faster, life couldn't exist. And it turns out that the universe is essentially at the critical density. we are very close. It's known as omega in physics. Here would be an open universe, here would be a closed universe. We seem to be right on that line where it is unclear if the universe is going to expand forever or it's going to close in on itself. So, in trying to explain the universe and Big Bang models, there's a big theory if you study cosmology called the theory of inflation, and that has to do with why is the cosmic microwave background radiation that I showed uniform. Everywhere you look, it's the same microwave background. To try to explain that, scientists came up with this theory, and why is it that we're so close to the critical density of 1 that the universe is nearly flat? So the only way we can explain it is something called inflation. Alan Guth at MIT was the guy who really came up with the idea of inflation. And it means that after the Big Bang, there was another period of very, very rapid expansion. And then the expansion slowed down. That's known as the theory of cosmic inflation. So in trying to study all these things, yet another startling discovery was made, the discovery of dark energy. Because everybody assumed, like I said, yes, the universe is expanding because of the Big Bang. Now that we all believe in the Big Bang, the universe is expanding, but that expansion rate will slow down. Will it slow down enough to recollapse? We don't know. Maybe it'll expand forever. Maybe it'll expand non-stop. Maybe it'll expand, slow down, and recollapse. Let's measure the matter density of the universe. As they started making these measurements, they realized that the universe is not only expanding, but that the expansion is actually accelerating, not slowing down the way all scientists from 1970 to whatever, 2015 or what have you, actually no, 1998, 1999, assumed. It turns out that the universe is not just expanding, it's actually expanding faster, which is very counterintuitive because gravity should have made it expand a little bit slower, and kind of put the brakes on that initial explosion. It turns out that it's expanding even faster. And nobody knows why that is happening. So there must be some energy within the fabric of the cosmos that is making it expand. We have no clue what this is, and we will call it dark energy. Dark because it's invisible to us. We have no insight into it. It is opaque to our minds and our instruments. How do we account now for dark energy in our scenarios of the universe? Well, we go back to Einstein's equations and we throw in the cosmological constant that he put in to balance the force of gravity. And they said, well, you know what? It turns out Einstein was right. Even when he was wrong and said the cosmological constant was the biggest mistake of my life, the man was right. There is a cosmological constant. It is balancing gravity, and that's what's making the universe expand. And so, right now, we believe that in terms of the universe, dark matter makes up 23%, atoms are less than 5%. Everything we know, everything we see, all what we call matter is just 5%. Dark energy is 72%. Remember, in Einstein's equations, that thing on the right-hand side, the mass energy momentum tensor, takes account of all matter, all energy, everything. Okay? So most of the universe is dark energy. We believe way back when the universe was born, it was a lot more matter, dark matter, and regular matter. And this dark energy seems to now be at the forefront. And so the cosmological constant remakes its appearance now in the equations of general relativity to account for dark energy. And we go back to our verse, وَالسَّمَاءَ بَنَيْنَاهَا بِأَيْدٍ. We have built it with power, with energy. وَإِنَّا لَمُوسِعُونَ. And we are expanding it. And we can now see that there are three types of expansion. The massive expansion during the period of inflation just after the Big Bang and the Big Bang itself, the steady expansion of the universe thereafter, and now the newly discovered acceleration secondary to dark energy. Is this the energy of bi'aydin, which means with power or with energy? Energy and power in physics, as you know, are the same concept. So again, this was entirely revolutionary, and it seems every year we get a little bit more insight into what this verse means. Yes, thank you, yes. And so another beautiful point of Arabic grammar, that the Qur'an did not say inna musi'un. It says, إِنَّا لَمُوسِعُونَ لام التأكيد. We are surely expanding it. We are certainly expanding it. Beyond doubt, we're expanding it, right? That's لام التأكيد. I hope we have an attendee for the grammar class, inshallah. Allahu Akbar. Okay, good. Yes, because I really think that the grammar does help understand the Qur'an, and we all realize that in the obvious point. And so, since we're very close to the critical density, remember again, if the universe is open, it keeps expanding forever. If it is closed, it will close in on itself, and if it is right at the critical density, it will just keep expanding, and maybe slow down to zero, or maybe instead of expanding at an ever-increasing rate, expand at a constant rate. If it closes on itself, this will be the big crunch. And just like dark energy wasn't there but is there now, if that cosmological constant that describes dark energy becomes negative, if it changes sign, all of the cosmological models we know, all of the scenarios that this equation predicts, is that the universe will close in on itself in a big crunch. And that big crunch is going to be good news or bad news. Allah subhanahu wa ta'ala knows best, but it will be the obliteration of everything we know. Everything will come back into itself in one massive crunch that will, of course, end not just all life as we know it, all life that we don't know, everything in the universe will come to an end. We have no clue. Yes, exactly. Allahu Akbar. Let's make the prediction and yeah. So I want to end then with our reflection on this verse, because it is now almost, I've really kept you for 2 hours. يوم نطوي السماء كطي السجل للكتب كما بدأنا أول خلق نعيده وعدا علينا إنا كنا فاعلين. On that day, we shall roll up the skies the way that written scrolls are rolled up by a scribe. The way we brought the first creation into being, so shall we return it. This is a promise that we have willed upon ourselves, and we are able to do all things. And so this is an amazing, yes sir?
Where we stand about black hole, science talk about black hole.
Oh yes, well we believe in black holes. I mean and again, black holes were one of the predictions of the equations of general relativity, and they were first predicted, yes sir?
After you answer this question, I'm going to continue on black holes.
Okay, wonderful. Give me one moment then. That to me, this verse is, well, as you can see, I'm a little overcome actually, because whenever I sort of think about this, the majesty of it, that Allah subhanahu wa ta'ala is saying, يَوْمَ نَطْوِي السَّمَاء كَطَيِّ السِّجِلِّ لِلْكُتُبِ, that we will refold them, just like we unfurled the scrolls, we're going to refold the scrolls the way we began the first creation, so shall we return it. This is a promise that we have willed upon ourselves. This is remarkable. And John Archibald Wheeler, in his book, A Journey into Gravity and Space-Time, Wheeler is one of the most famous theoreticians of general relativity. The big textbook of general relativity is Meissner, Thorne, and Wheeler. Kip Thorne is at Caltech. Wheeler was at Princeton. This is taken from his book. He was absolutely amazed that the Qur'an said this. We shall roll up the heavens like the rolling up of scrolls by a scribe. As we began the first creation, so shall we repeat it. And Wheeler put this picture and this verse in his book because he was just awestruck that the Qur'an was talking about this. So before I answer the questions, then I'll thank you for your attention. I hope that I did not overtax you. There's a lot more to talk about, both in physics and in biology and so on. And I hope, inshallah, this will be the first of a series, if God wills. But I hope I've brought you a little bit of a different vision about, the relationship between Qur'an and science, and encouraged some of the young and some of the old to Pay attention in math class, pay attention in physics class, do work on your own. You will be rewarded many, many fold in the richness of the understanding of the Qur'an. Just the same as if you study botany, it's not just the same as you study Arabic, it's all a yield. Yes, my brother. Sorry.